All right. Question 8, is asking about dilation. So we're given this figure here, and we have to dilate it. And so we just really have to appropriate one of two strategies. The first strategy is really dealing with just coordinates. I left a space here just so you could write the coordinates out if you wanted to do that instead of just say manipulating them in your head or on a calculator. So essentially we're just going to take these coordinates and we're going to multiply them by 2.5 and produce new coordinates. And as soon as you produce those new coordinates, you can plot those on the grid, right? And so nothing really too mind-bending here in terms of like the strategy. We just take the old coordinates times 2.5 for the new coordinates, and then we have it. Now, in terms of evaluating your results, you do want to make sure it passes like the visual test. And there's two main parts of the visual test, or three main parts, excuse me, the visual test. So one, like your corresponding sides have to be reasonably congruent, or I'm sorry, not congruent, but parallel. And I think these look reasonably parallel. We could actually calculate the slope if we needed to, but it is just like a visual check to make sure you did it right. And so I don't think that's probably necessary. The second check is lines of dilation. And so if I connect corresponding vertices and trace them back, do they all hit in the same exact spot? If they do, that means it's going to be a dilation. If they don't, that means it's not. And of course, that's the way they do. The other thing to kind of keep in mind here in terms of how to perform a dilation, there is more than one way to do it. This way is perfectly fine, particularly if you have a grid. But keep in mind this can be done without the use of a grid. I'm not going to remove the grid for this particular point I'm trying to make, but I just want to remind you of something. Everyone here has performed a dilation by simply taking the distance between center dilation, in this case it's the origin, to any of the vertices. And when I say take the measurement, I do mean like literally take the measurement, like grab a ruler and measure the thing. How come it's not spinning now? Huh, weird. Okay, anyway, so, oh, there goes. That's what I need, right there. Okay, so, take the actual measurement in centimeters probably, multiply it by 2.5, and then extend that out, right? And if you do that in all the different directions, that can also accomplish the dilation. Especially if you don't have a grid, that might be the best way to do it. Take the distance between here and A, multiply that distance, a literal measurable distance, by 2.5, and then extend that out. Especially if you don't have a grid, that might be the only way you could do it, right? So just a quick word on dilations. I'll see you in the last question, I think, or second last question.